Think of a number, quick! If your number is even, you divide it by 2, and if it's odd, you multiply it with 3 and add 1. And now you repeat this process until you reach 1. The interesting thing is that no matter which number you chose, you will eventually terminate at 1. This is called the Collatz Conjecture, and today we'll visualize it with Python. Let's dive into some thoughts of code. As I've already implied, a Collatz conjecture starts with a number, for example 3. Since it is odd, we'll multiply it with 3 and add 1, which equals 10. 10 is even, so we'll divide it by 2. Now we will repeat this process until we get to 1. In total, it takes 7 steps for 3 to reach 1. A small program to get the total steps for a number to terminate looks like this. In a code editor of our liking, we create a new Python file and then we'll initialize a number of our liking and a steps variable. Now, while the number is unequal to 1, we check if it is divisible by 2 and then halve it, or else multiply it with 3 and add 1. Also, for each iteration of the loop, we add to the steps variable, and for printing the starting number in the end, we also declare a starting number. At the end, we can print the steps and the starting number. To recreate this visualization, we'll import Matplotlib and download it with pip install Matplotlib. To show the first 50 numbers, we write a for loop and reuse the while loop, the steps variable and if statement from our basic program. To store the data points, which we are going to visualize later, we initialize an x and y array to store the number and step data. As the last thing in the for loop, we plot the graphical line of this number so that all of the for loop numbers get an individual line. Finally, we can show all the graphs with all these lines that do all these wonderful things. In the second visualization, we want to show the total amount of steps needed to get to 1 for each starting number from 2 to 100,000. So this time we'll append the starting number, which is I, and the steps variable to the x and y arrays after our initial while loop, and this time scatter all these data points onto the canvas after the for loop. Let's visualize, and it works! In our last visualization, we want to show the highest number reached for each starting number from 2 to 10,000. So this time, instead of the steps variable, we use a highest number variable, which will be set to the current number if it is higher than the highest number. And again, we'll append the starting number and the highest number to the x and y arrays. And finally, visualize these arrays. If we zoom in a bit now, we'll see this unexpected pattern. So now you sure know what a Collatz conjecture is and how to handle it in computer science. Also, you learned how to deal with Matplotlib, a tool that will for sure cross your path again.